Hi everyone, welcome back to my channel. So in today's video, we are going to discuss the top 15 important NumPy functions for data analysis. So let's get started. So the very first NumPy function is numpy.array. So this function is used to create a NumPy array from lists, tuples or other array-like objects. The syntax of this function is numpy.array. In the bracket, we would like to mention the data that we like to represent in the form of the array. So here is the basic example of implementing this function. So guys, we are just going to implement these examples in Google Colab once we go through all the NumPy function. Now coming to the second function, which is numpy.arrange. So this function is used to create an array with evenly spaced values within a specified range. So the syntax of this function is np.arrange start, stop, step. So here the start is the value from where we would like to create the array, and stop is the value where we would like to just stop our range, but the stop is exclusive here, and step is nothing but the step size that we would like to mention. So here is the basic example. So here 1, 10, 2. So 1 is where we are going to start our range, and 10 is exclusive, so it is skipping two step size. So 1, 3, 5, 7, 9 is our output. Now coming to our third function, which is numpy.linespace. So this function creates an array of evenly spaced values between a specified start and end point. So the syntax of this function is np.linespace start, stop, num. And here is the basic example where 1 is the start value and 10 is the stop value and 5 is nothing but the number of values in our numpy array. So in this case, the value is just getting started from 1 and the value is ending at 10, and here we would like to mention 5 values. That's how the line space function works. Now coming to the fourth NumPy function is numpy.reshape. So this function changes the shape of an existing array without modifying its data. The syntax of this function is np.reshape and the array that we would like to reshape and the new shape in the form of rows, columns. So here np.reshape, so this is our array and new shape that we have defined. So the new shape should contain 2 rows and 2 columns. So here the left side we mentioned the number of rows and the right side we mentioned the number of columns. So we have got 2 rows and 2 columns. So this is actually reshaped our array. Now coming to the fifth NumPy function, which is numpy.random. So this function generates random numbers or samples from distribution. The syntax of this function is np.random. In the bracket, we are going to mention the size. So for example, here we have mentioned 3. So that's how it has generated 3 random values. Now coming to the sixth function, which is numpy.dot function. So this function performs the dot product of 2 arrays. For matrices, it performs matrix multiplication. The syntax of this function is np.dot a, b. So here is the example of this function. Here this is my first array, this is my second array, and the dot product of this is coming out to be 11, which is 1 into 3 plus 2 into 4, which is equal to 11. Now coming to our seventh function, which is numpy.linearalgebra.inv and numpy.linearalgebra.det, which is just used to compute the inverse indeterminant of a matrix. So basically, inv compute the inverse of a square matrix, while determinant det calculates its determinant. The syntax of this function looks like this. And here is the basic example of implementing this. So you can see here, in this case, it has just computed the inverse of this matrix. So this is our matrix and it has just computed the inverse of this. Similarly, we can just calculate the determinant as well. Now coming to the eighth function, which is numpy.unique. So this function returns the sorted unique values from an array. Now, the syntax of this function is np.unique, and in the bracket we would like to mention the array. So this is the example of implementing this function. So here we can see that it has removed the duplicate values. Now coming to the ninth function, which is numpy.sort. So this function sorts the elements of an array in ascending order. The syntax of this is np.sort. In the bracket we would like to mention the array. That now here the example of this function is np.sort, and it has just sorted the array. So one thing to note that here is it sorts the array in ascending order by default. Now coming to the 10th function, which is numpy.concatenate. So this function combines multiple arrays. So it joins 2 or more arrays along a specified axis, and this is the syntax of the function, and this is the example. So it has concatenated array 1 and array 2. 1, 2 was array 1, 3, 4 was array 2, and here 1, 2, 3, 4 it has just concatenated it. Now coming to the 11th function is numpy.where. So numpy.where returns the indexes of the elements that satisfies a given condition. So the syntax of this function is np.where, and in the bracket we would like to mention the condition. So the example of implementing this is, here we have mentioned the condition that the array should be greater than 2. So that's how it has just computed our result based on the condition. Now coming to the 12th NumPy function, which is numpy.max and numpy.min. So this function is used to find the maximum and minimum values, where max returns the highest value, that is the maximum value, and min returns the minimum value. The syntax of this function looks like this, and here is the example where we can see that np.max, it has computed the maximum value, which is 5, and np.min, where it has computed the minimum value, which is 1. Now coming to the 13th NumPy function, which is numpy.argmax and numpy.argmin. So wherever, just one thing to note, that wherever this argr comes in, it will actually find the indexes of the maximum value and the indexes of the minimum value. So argmax returns the index of the maximum value, while argmin returns the index of the minimum value. The syntax of this function looks like this, and here is the basic example. So in this case, our maximum value was 5, and the index of this maximum value is 1, 0, 1, 2. So this is 1. Again, the index of the minimum value, since minimum value is 1, the index of this minimum value is 0. Now coming to the 14th NumPy function, which is numpy.zeros. So this function creates an array filled with zeros of a specified shape and data type. The syntax of this function is np.zeros, and in the bracket we would like to mention the shape. Shape is nothing but the number of rows and the number of columns. So here in this case we have mentioned the shape 2, 3. So it has given us the array with the number of 2 rows and 3 columns. And the last function is numpy.ones. It has created array of ones. So this function creates an array filled with ones of specified shape and data type. The syntax of this function is np.ones. In the bracket we would like to mention the shape of the array. For example, np.ones 2, 3, it has computed the array with the 2 rows and 3 columns. So these are the 15 NumPy functions that you must know. Now let's implement each of these functions in Google Colab. So guys, let us implement each of the NumPy function that we just discussed. So our first function was numpy.array function, which is used to create a NumPy array. So guys, let's first import our NumPy. So NumPy, as I'm just giving as alias np. Now I will just create a 1D NumPy array. So let's understand how to create a 1D NumPy array. So I am just going to create my np dot array, and here in the bracket I would just like to mention the array. Okay, so it will just give me the 1D NumPy array. Now let's create a 2D NumPy array, and I am going to again use my function np.array, and since it is 2D NumPy array, so 1, 2, 3, and here I am going to give another list which is 4, 5, 6. So this is my 2D NumPy array, which has array 2D. What is the error? Okay, since this is not 2D, I will have to do one more bracket. Okay, so this is my 2D NumPy array now. So here it contains 2 rows and 3 columns. So this is my 2D NumPy array. Now coming to my second NumPy function, which was numpy dot arrange. So this is just, as we know, this is used to generate a range of values. Now as we know, the syntax of this function was np.arrange, and here if we would like to mention the start, so let's just start it from 0 and end it at 10 and give the step sizes 2. So in this case 10 is exclusive, so it will just start from 0 and will end at 8. So 0, 1, 2 is the step size, so 0, 2, 4, 6, 8, and since we cannot include 10, so it has stopped it over there. So that's how it is going to work. Now coming to the third function, so third function was numpy dot line space, which is used to generate linearly spaced values. Now let's just implement it. So let's say I'm just going to create an array with np dot line space, and here I'm just going to give the start, stop, and the num. So my start will be, let's say 0 will, one second, my start will be 0, my end will be 1, and I'm just want to find 5 numbers. So so this is the number of number of values that we want in my array. So I want 5 values starting from 0 ending at 1. So if I just run this and I just print array, what I will be getting is I'm getting 5 numbers, 1 2 3 4 5 numbers starting from 0 ending at 1, and they are linearly spaced. Okay, the step size is same. Now coming to my next NumPy function, which is NumPy.reshape. It is NumPy.reshape. So what was it used for? It is used to reshape a NumPy array. Now, okay guys, so let's first create a NumPy array. So this is my NumPy array. So this starts from 0, ends at 5. So it has 6 elements in total. So what are the ways to reshape this array? So the ways to reshape 6 elements is 2, 3, 3, 2, 1, 6, 6, 1. So that's how we can just reshape it. So let's just reshape it. So dot reshape in 3, 2. And now if I see, it has reshaped it in 0, 1, 2, 3, 4, 5. So here we can say 3 columns and 2 rows. This is how it has reshaped it. Now if I want to reshape it in, let's say this is my array 2, and I just want to reshape my array in reshape in 2, 3. Then it will reshape it into 2 rows and 3 columns. So 0, 1, 2, 3, 4, 5. As you can see here, 2 rows are there, 3 columns are there. So that's how reshape function works. Now coming to my 5th NumPy function, which is NumPy.random. So this is used to generate random numbers. Okay, so here let's just generate some random numbers. So let's say this is my array 3, and here I'm just going to write np.random, and let's say I just want to compute the random matrix having 2 rows and 2 columns. So this is the shape of my matrix. So 1 second guys, here I will have to open one more bracket since this is my shape. And now if I just write array 3, then you will be getting some. So guys, there is one more function to generate the random integers, which is random np. So let's say this is array 4. So np dot, so wherever, like if I just, it just keeps on changing. So whenever I just do run it again, it just, the numbers keep on changing. As you can see, the numbers keep on changing since these are the random numbers. So if I just random dot rand integers, so here if I just start, so my random number should start from 1, and the random number should end at 100. So my random numbers should range from 1 to 100, and let's say here I would like to give the size, let's say 4, 5. So here what I will get is, so this is the 4 columns, 5 rows, and my all these random numbers are between 1 and 100. Okay, so that's how it's just going to work. Whenever I rerun it, you can see my random numbers keep on changing since these are the random numbers. Now coming to my 6th NumPy function, which is in NumPy.dot. So this is used for matrix multiplication, as we already know. Let's say I have matrix, so this is my NumPy array. So np dot array, I'm just creating a NumPy array guys, a, and this is my matrix 1, and I'm just creating my another matrix. So 1 2 3 4, and the basic one, let's say it's like 5, 6, and here it's just going to be 7 comma 8. So now I just want to do a dot product of the above matrix. So if I just print A, what I'll be getting is this, and if I just print B, what I'll be getting is this. So 1 second, print A and then just print B. Now I just want to do a dot product of this both, so that is going to be my result. So np dot dot, and in the bracket I'm just going to write a comma b. So this is here I will just want to mention the result. Okay, so my result is going to be the dot product of a and b. So this is my dot product of these two matrices. Now coming to the next NumPy function, which is NumPy dot inv. So it is just going to compute the inverse of this matrix. So if I say this is my matrix, and let's just compute the inverse of this, so it will just apply this function np dot this, and here in the bracket we are just going to mention the matrix. So it will just print I and b. So it has just computed the inverse of this. Similarly, we can just compute the determinant of this. So this is the inverse matrix, and here we will just find the determinant of a matrix. So again, this is my matrix. Let's say I just want to calculate the determinant of it, so det. So I will just make use of this function, which is my det function, and yeah, so my determinant is going to be here. Okay, now guys, the next function is np.unique. Okay, so this function actually returns the unique elements in an array. So let's say your array is np.array. In the bracket I'm just going to write 1 comma 3 comma 4 comma 4 4 comma 4 comma 2 comma 2 comma 6 comma 8 comma 3 comma 3, something like this. And let's say I just want to print unique. Let's me unique is equals to, I'm just going to use this function, which is my unique function over here. So np.unique in the bracket array, and here I will just print unique. Okay, so what it has done is it has actually removed the duplicates, and it has returned the unique elements in a sorted order. Okay, now coming to the next function, which is my sort function, which is np.sort, which is actually used to sort an array. So guys, in this case I am just going to write my array. Let's say this is my array. I'm just creating a NumPy array 5 comma 7 comma 1 comma 3 comma 2. Okay, now I just want to do a sorted array, so I'm just going to use my np.sort function, and in the bracket I'm just going to write my array, and here I will just print my sorted array. Okay, so as you can see, this has sorted my array in ascending order by default. Now coming to the next function, which is my concatenate function. So np.concatenate. So this function combines the multiple arrays that we already know. Now let's just concatenate the arrays. So I'm just writing one array here. So let's say 1 comma 2 comma 3, and then b is equals to np dot array, and this is again like 4 comma 5 comma 6. So if I just do concatenation on this, so this is my concatenated result, np dot concatenate, and in the bracket I'm just going to write a comma b, and I will just print my result over here. So what it has done is it has concatenated my both arrays, array A and array B. Now my next function is numpy.max and numpy.min. So here it is. So if I just find the maximum of this, let's say I'm using the same array here, and let's say max is equal to np dot max of a. So what we will be getting is max of, which is 3. Max of array, and you've got 3 here. And similarly, if you will be doing for the min, so again you will be getting, so min is equal to np dot min of a. So here you will be getting min. So I'm just going to print my max, and again I will just print my min. So 3 and 1. So this is my max and this is my min. So that's how you can just make use of min and max function. Now coming to my argmax and argmin. So what it gives me is the indexes of the minimum and the maximum function. So numpy dot argmax function. So if I just use, let's say 3 comma 6 comma 0 comma 7 comma 8 comma 10. So in this case, let's just calculate the index of the maximum value. So to calculate the index of the maximum value, so max index, let's say, and I'm just going to make use of this function, which is numpy.argmax. So in this case, our maximum value is 10, and what is the index of this is 1 2 3 4 5 6 7 8. So 0 1 2 3 4 5 6 7 is the index of this. So if I just do a, then I will just print max index, and I should get 7. One second, np dot argmax of a. Okay, so as you can see that you have got 7 here. Now similarly, what you can do is you can also find the minimum index of the minimum value. So index of the minimum value is again going to be, I'm just going to use argmin function, and in the bracket I'm just going to write a. So min is 0 here, and what is the index of this 0 value is 0 1 2 3 4. So the index of this is going to be 4. So since our indexes start from 0, so print min index, so it's going to be 4. So as you can see, that's how we can just make use of argmax and argmin function. Now guys, what is my last, I guess second last, so this is my zeros, numpy dot zeros function. Okay, it is zeros. Okay, now coming to this, this is just used to create an array of zeros. So if I just want to create an array of zeros, zeros, and here I'm just going to mention the shape of it. So shape should be, let's say, 3 rows and 6 columns. Then what will I get? So here you got the 3 rows and 6 columns having 0 values. So that, and similarly, that's how my numpy dot ones works. So guys, my last function was numpy dot ones. So let's just implement it. So let's say I just want to create a numpy array. Let's say array of ones. So here I will just make use of ones function, and in the bracket I'm just going to mention the shape of it. So just the parameters of the shape is like the number of rows and number of columns. So here I'm just going to write, let's say, 3 rows and 1 column, and it will just print array ones. Second. So as you can see, it has given me 3 rows and 1 column with an array. Also, I can just change it. If I want 3 rows, 7 columns, that's how it's just going to change. 5 rows, 7 columns. So 1, 2, 3, 4, 5, 7 columns. So that's how the numpy.zeros and numpy.ones function works. So that's all about all these 15 numpy functions. I hope you understood. So that's all about this video, guys. Let's meet in the next video. Thank you.